Okay, so have you ever felt like you're drowning in company info?
Oh, yeah.
You know it's out there somewhere, but actually finding it feels impossible.
Like searching for a lost city, right?
Exactly. Spreadsheets, emails, that one document someone mentioned in a meeting like forever ago.
You're not alone.
It's a productivity killer.
Absolutely. It's information overload, and it's a huge drain.
And even when you find something, who knows if it's even right or current?
Exactly.
So is that where this whole REG thing comes in?
You got a retrieval-augmented generation, or R.
Retrieval-augmented generation.
Yeah, it's like imagine a super-powered research assistant who's already read everything at your company.
Okay, I'm intrigued.
So no more wasting time digging through endless files.
You just ask, and boom, answer, sourced right from your company's own knowledge.
Exactly, and especially in bigger companies where knowledge gets siloed.
Oh, tell me about it.
Suddenly everyone's on the same page with the right info. Could be a game changer, for real.
That all sounds amazing, but there's got to be a catch.
Well, the magic of RAG kind of depends on one thing, the database behind it.
The database.
It's like building a house, right? You could have the most amazing design, but if that foundation's shaky.
The whole thing crumbles.
Exactly.
So the database, that's the bedrock of your whole RAG system.
You got it. Choose wrong, and your AI is basically just making stuff up.
Yikes.
But choose right. You got yourself a knowledge powerhouse.
Okay, so today we're going database shopping then.
That's right.
We've got 3 contenders.
Each with their own strengths and weaknesses, yeah.
By the end, you'll know exactly which one is right for you.
Let's do it.
So up first, we've got vector databases.
Imagine taking all your company's data, turning it into this huge map of points.
Okay.
Each point is like a chunk of info, and similar chunks are grouped together.
So if I was looking for, say, info on marketing budgets,
Yeah.
the vector database would show me all the data points related to that topic.
Exactly. It's like, you know those image search things where you upload a picture and it finds similar ones?
Yeah.
Vector databases kind of do the same, but with words, concepts.
That's pretty neat, actually.
Right.
But I'm guessing there's a downside.
Well, remember we were talking about context before?
Yeah.
Vector databases, sometimes they miss the nuances, you know?
Really?
They're good at finding similar info, but not always good at understanding how those pieces actually fit together.
Ah, so it's like getting a bunch of puzzle pieces, but no picture on the box to see how it's supposed to look.
Got it.
So maybe not the best for understanding the why behind the what then. What's next?
Next up, graph databases. And as the name suggests, they're all about relationships.
Relationships. Okay.
They're amazing at showing how different bits of info connect to each other.
So if vector databases are like individual puzzle pieces,
Yep.
graph databases show you how the whole puzzle fits together.
Precisely. Like think about social networks, financial transactions, even how different departments in your company are connected.
Okay, yeah, that's a lot of connections.
Great. And graph databases are great at handling that complexity.
Sounds impressive, but got to be a trade-off somewhere, right?
Well, the challenge is they can get bogged down with huge amounts of data. As the data grows, the connections explode and things can slow down.
So maybe not the best for speed and scale then. All right, let's meet our final contender.
Our last one is the knowledge graph, often considered like the most sophisticated of the bunch.
Ooh, fancy.
Right. Knowledge graphs, they go beyond just connecting data. They actually try to like mimic human understanding.
So they don't just see that, say, coffee and morning are related.
Right.
They understand that people often drink coffee in the morning.
Exactly. They get the why, the how behind those connections for more accurate results.
Okay, so it's like the difference between knowing the ingredients for a cake versus having the actual recipe.
Perfect analogy.
One gives you the facts, but the other lets you actually bake the cake.
Exactly. Exactly. And just like a good recipe book, organization is key, right? A knowledge graph uses structured relationships to make sure you're getting accurate info.
Okay, so I'm really seeing how these are different, but how do they work in the real world?
Right.
Like if I'm asking a question, how do I know which database is going to give me the best answer?
That's the million-dollar question, isn't it?
It is.
Let's say you're trying to find something specific, like find me information on the impact of last year's marketing campaign on Q1 sales.
So a pretty specific question.
Right.
What happens?
So you go to your vector database with that.
Okay.
And remember, it's looking at those individual data points.
Right.
It might find marketing campaign, it might find Q1 sales,
Okay.
even impact. But it doesn't really get the context. So you might end up with a jumbled mess.
like getting bits and pieces of the answer, but not the whole story.
Exactly. Some reports, some sales figures, maybe even a random email about the office coffee machine, just because it mentions Q1.
Okay, so not ideal.
Not really helpful, no.
What about the graph database? How does it handle that same question?
Now, the graph database, with those relationships in mind, it has a better shot.
Okay.
It can see marketing campaign linked to Q1 sales
Yeah.
and understand that impact connection.
So more likely to give me an answer that actually makes sense.
Exactly. But the more data you have, the more complex it gets,
Right.
and the longer it might take to process.
So it's a trade-off, accuracy maybe, but at the cost of speed.
Could be, yeah.
Okay, all right. Let's see what the knowledge graph can do.
Now, the knowledge graph, it's like having a detective on the case.
Ooh, I like it.
It doesn't just see the connections, it understands them.
Okay.
For example, it might know that impact, in this case, means something specific,
Yeah.
like customer acquisition cost or return on investment.
Whoa. So it's not just finding the info, it gets what I'm actually asking.
Precisely. And that means it can filter out all the noise
Yeah.
and give you a much more accurate answer.
That's really impressive. Like having a research assistant who not only knows where to look, but also how to interpret it all.
Right.
But hold on, what about the quality of the information itself?
Ah, good point.
Even the smartest AI is only as good as what it's given.
Right.
Like,
Absolutely.
bad data in, bad answers out.
We call it the garbage in, garbage out problem, and it's huge.
Right. So how do we make sure we're feeding our AI like a healthy diet of data?
That's the key, isn't it?
Let's start with vector databases. How do they do it?
So vector databases, because they break things down into those chunks,
Yeah.
they're more likely to lose context or misinterpret something.
Like trying to make a cake by just looking at a random list of ingredients?
Exactly. You might put salt instead of sugar.
Exactly.
So you need really, really good data cleaning.
Okay.
Think of it like having a team of chefs, making sure every ingredient is perfect, labeled perfectly, before it even gets to the database.
So a lot of work up front to avoid a disaster later.
Pretty much. Yeah.
Makes sense. What about graph databases?
Now, graph databases, they're better at keeping things in context because of those relationships.
Right.
They can help spot inconsistencies, things that don't quite add up.
So it's like having another chef double-checking the recipe.
Exactly. But even then, you still need good processes.
To make sure everything's running smoothly.
Yep. Especially at scale.
Right, because everyone makes mistakes.
Exactly.
Okay, last but not least, let's see how our knowledge graph champ handles this.
The knowledge graph, because it understands meaning, it's already better equipped to deal with this stuff.
Okay.
It can spot inconsistencies that other databases might miss completely.
So it's like a master chef who can not only follow the recipe, but can also tell if an ingredient's gone bad.
You got it.
Wow, that's next level stuff.
Right. And a lot of them actually use things like natural language processing.
Okay, to like automatically clean and organize the data.
Exactly. So they're not just understanding the information, they're actively making it better.
That's really cool. So it seems like there's a lot to think about when choosing a database for ag.
Oh, yeah, for sure.
It's not just a one-size-fits-all kind of thing.
Definitely not.
You really got to consider your needs, how complex your data is, how accurate and fast you need things to be.
Those are all key factors.
But it sounds like for bigger companies especially, with tons of data, knowledge graphs have a serious edge.
For sure, they combine accuracy, scale, and data quality in a way that's hard to beat.
Right, it's like having a whole team of super-powered research assistants at your fingertips.
Exactly. But, and this is important, technology is just one piece of the puzzle.
True. At the end of the day, it's about people using this technology, right? Yeah, it's like giving people the tools to actually use all that information, right? Not just find it.
Exactly. Imagine anyone in your company being able to find the info they need when they need it.
And actually being able to understand it, actually use it.
Exactly. That's the real power of RAG.
No more digging through old files, no more endless email chains. It's like
having all that company knowledge at your fingertips.
right. And not just finding answers, but like uncovering stuff that you didn't even know you were looking for.
Exactly. You start connecting those dots, seeing patterns.
Seeing the bigger picture instead of just your little corner of it.
Right. And that changes everything.
It does. Collaboration, decision-making, the whole organization becomes more, I don't know, agile. So we've talked tech, we've talked benefits, data quality, all that good stuff.
We have
But before we wrap up, I gotta zoom out a little bit, you know?
the bigger picture.
Yeah, because at the end of the day, technology is just a tool, right?
It is. It can be used for good or for bad.
Exactly. So as we're entering this new era of AI-powered knowledge, what do we need to be careful of?
Well, first off, we got to make sure it's accessible to everyone.
Right. Can't have just a select few with all the best info.
Exactly. Everyone should benefit.
Otherwise, we're just making existing inequalities even worse.
Exactly. And the other thing, we got to be really careful about bias.
Oh, right, because the data itself can be biased.
It absolutely can. And if we're not careful, we'll just end up amplifying that bias in all sorts of ways.
It's like that saying, garbage in, garbage out.
Exactly. So we need good data, representative data.
And ways to identify bias when it does pop up.
Need systems to deal with it, yeah.
Sounds like a lot of responsibility comes with this powerful technology.
It does, but it's also a huge opportunity.
To do things better, to be fairer, to be smarter.
Exactly.
Well said. This has been a really amazing deep dive.
It has.
I feel like I learned a ton about the tech, about the bigger picture of it all.
It's always a pleasure talking about this stuff with you.
Likewise. And a huge thank you to everyone listening. We hope this was helpful, insightful.
Absolutely. If you want to learn more, check out the show notes. We got links and stuff there.
And as always, we love hearing from you. Hit us up on social media. Let us know what you thought.
What questions you have, what you want to talk about next time, all that good stuff.
And that's a wrap on another episode of The Deep Dive. Thanks for listening.